Sa ating YouTube channel. So, ang topic natin ngayon ay about sa deflection of beams using virtual work method. So, same concept ang gagamitin natin, just like in trusses. We're going to compare the virtual external work, equating it to the virtual internal work. So, for the virtual internal work, we have what? As we recall this is virtual internal force multiplied by the real internal displacement. So, ang internal displacement natin sa kahit saan panig yan, meron kang differential angle d theta kasi magde-deflect to, no? And from strength of materials, we know that d theta is equal to what? M over AI dx. Okay? So, kung kukuha tayo ng isang virtual system, either this one or this one, given we have a simply supported beam na ganito yung loading, it's up to you kung ano yung kukunin kasi natin, kung deflection or slope. So, kung gagawa ka ng virtual system, kung gusto mo ng deflection, kailangan mo mag-apply ng 1 unit load, okay, concentrated load dun sa point of consideration. In this case, point B. So, dito yon. Kung slope naman, ang may concern dun ay moment. Okay? So, we have a sign convention here na counterclockwise moment yung lalagay natin, no? With a unit value. Okay, 1 po yun. So, ang gagamitin nating symbol for the moment sa real system is capital M. Ito yon. Whereas, sa virtual system, ang gagamitin natin ay small letter m. Okay. So, makikita natin dito, ang virtual internal force natin is yung moment sa virtual system, which is yung small m. So, getting the virtual internal work, in this case, makukuha natin is differential work, no? Kasi differential theta lang to, or d theta. So, we have what? Virtual internal force na small m times real internal displacement na d theta. Okay? And then, substituting the value of d theta, which is this, rearranging, we have capital M, small m over AI. This is dx po, no? Kamali lang ng sulat. Okay, this is dx. So, para makuha mismo yung virtual internal work, we're going to integrate to sum up everything. So that the virtual internal work is equal to what? Okay, this familiar mm over AI dx, in which the virtual external work is equal to what? Okay, 1 times either theta or delta, depende kung anong kinukuha mo, kung slope man or deflection. So, ano po ba yung procedure dito? So, just like what we did doon sa trusses, kung saan mo gustong kunin yung deflection, doon ka mag-a-apply ng unit load, just like this one. Gusto mo makuha yung deflection sa point B, maglagay ka ng unit load 1 doon sa point B. Kung gusto mo na ng ng slope, maglagay ka ng moment no 1 doon sa point of consideration. In this case, again, point B. So, we have here some examples. On our first example, use virtual work method to determine the slope and deflection at point B of the beam shown. Okay, so we have a 9-meter cantilever beam with the first 3 meters here has a moment of inertia twice than of the next 6 meters hanggang dulo. Okay, so in this case, mas effective gamitin yung virtual work method kapag varying na yung moment of inertia. Okay. So, kailangan tayo magpass ng cutting plane doon sa point or sa segments na may discontinuous na system. Moment of inertia or loading. So, in this case, we have 2 segments. We have segment OA and we have segment AB. Bakit po, sir? Kasi sa segment OA, iba yung moment of inertia niya doon sa segment AB. So, we need to split this into 2. Okay? Dito naman sa AB, continuous naman yung loading starting from here up to here. So, wala naman tayong problema doon. Given that, ang point of origin na gagamitin natin is point O. Okay? Mahalaga po kasing malaman natin to, no? Kailangan, kung gusto mo magsimula dito, kailangan lahat din ng loading continuous from the point of origin. So, in our case, point O yon. So based from statics, nakalagay na rito yung reactions dun sa cantilever. We have 72 kilonewtons upward and 432 kilonewton meter na moment. Okay? So magpass tayo ng cutting plane sa segment OA. Ito po yung makikita natin. Alright? So, by summing up moments, okay, kunin natin yung point, yung moment, no? So what is this? We have M plus this 432 minus 72x equal to 0. Okay? Rearranging, we have what? M equals what? Negative 432 plus 72x. Okay? So, yan po yung ating moment equation to segment OA lamang po yan. How about this one? Paano naman ito? So, ganun din. Same process. We have M plus 432. Same pa rin present pa rin minus 72 times X. Okay. And then plus this one. Plus to, no? Yung resultant niya ay how much? 12 times X minus 3. Alright? So, 12 times X minus 3 times moment arm, kalahati ng X minus 3. Equal to 0. So, rearranging and simplifying, we have what? M is equal to what? Negative 432 plus 72x minus 6 times the quantity X minus 3 squared. So, this is our moment equation from point A to point B. So, tandaan po natin yan. Na? Ito po yung sa rail system. Okay, take note that our moment of inertia is 500 times 10 raised to 6 millimeters to the 4th power and modulus of elasticity 70 gigapascals. Punta tayo ron sa virtual system. Since dalawa yung pinapahanap sa atin, slope and deflection at point B, unahin natin yung dito sa slope. So, naglagay tayo ng unit couple or unit moment dito sa point B, counterclockwise. So, 1. So, ang reaction dito is clockwise na 1. Medyo obvious naman yon. So, nilagyan ko lang ng subscript na theta to determine that this is for the slope. Ito yung ating virtual system. So, ganun din yung gagawin natin. So, we have m sub theta counterclockwise minus 1 equal to 0. So, m sub theta is equal to positive 1. In the same manner, pagdating dito, walang magbabago. Okay? So, same lang naman yung makikita natin. So, we have m sub theta minus 1 is equal to 0. So, same lang, m sub theta is equal to positive 1. Okay, ito po yung yung moment equation natin for the slope. For the deflection naman, naglagay tayo ng 1 unit load, concentrated load pababa, dun sa point B. So that magre-react yung fixed support dito, may 1 dito, and may moment na 9. So, nilagyan ko lang ng subscript na delta to indicate that this is for deflection. So, what is m sub delta? M sub delta plus 9 minus 1 times x equal to 0. Alright? So, m sub delta is equal to what? Negative 9 plus x. That's for segment OA. Pagdating naman dito, same lang din. So, m sub delta plus 9 minus 1 times x equal to 0. Okay, same lang, no? So, m sub delta is equal to what? Negative 9 plus x. Okay? So, mas maganda to, katulad ng ginawa natin sa plane trusses, mag-tabulate tayo ng results. And these are as follows. So, we have two segments. We have segment OA and segment AB. So, parehas tayong nag-originate sa point O. So, ilalagay natin yun dito. Okay? For the limits, mula saan ba yung segment OA? Okay? Given that the origin is from point O. So, we have from x equals 0 up to x equals 3 meters. And for AB, we have what? X equals 3 meters up to 9 meters. Okay? So, kaya natin hinati yan. That's because yung moment of inertia ay nag-vary doon sa ano na yon, sa segment na to, no? So we have 2i here, we have I here. Okay? So yung moment equation natin, ilalagay natin siya. Yun yung kinuha natin kanina. Okay? And for m sub theta and m sub delta, these are as follows. Okay, let's focus first dito sa column na to, sa pagkuha ng slope. So, paano natin kukunin yun dito? First portion. So, para dito, i-assemble lang natin, we have what? Integral of what? Capital M, which is negative 432 plus 72x times m sub theta na 1 dx. Oops, okay, yan, dx over ei. But take note, yung I dito ay 2. So, napakahalaga nun. So, e times 2i from what? 0 to 3. So, kuha tayo ng calculator and then this is equal to 46 of, rather, negative 486 over ei. Okay, so ilalagay natin yan dito. Negative 486 over ei. How about the second one? Okay, so we have what? Integral of negative 432 plus 72x minus 6 times the quantity x minus 3 squared times 1, ito yon, over ei. Okay, kasi 1 na lang yung I dito, no? Okay, dx from 3 to 9. Okay, and this is negative 432 over ei. Okay, lagyan natin dito. Okay, so after which, nakuha na natin tong dalawang concern natin. So, sum up natin lahat yan nandito. Then, we will get, okay, ayun, negative 918 over ei. Okay, so this is already the slope at that point. Pero what is the significance of negative? Ibig sabihin, yung direction ay salungat dun sa direction nung 1 na moment na nilagay natin. Ibig sabihin, kung kanina ay clockwise or rather counterclockwise yung unang nilagay natin, which means, okay, the slope here is 918 over ei clockwise. Okay? So, later, mamaya, i-substitute natin yung values ng e tsaka ng I na given. So, for the meantime, focus naman tayo rito sa column na to. So, paano naman ito? We have what? Integral of negative 432 plus 72x, ito yon, times the quantity negative 9 plus x dx over ei. But yung I niya ay 2i is from 3 to 9. Okay? So, konting ingat lang. Lagay natin yung values or yung equation sa calculator and we have, okay, positive 3,726 over ei. And just like this one, okay, sulat muna natin, no? Yan. Ito naman, we have integral of what? Negative 432 plus 72x minus 6 times the quantity x minus 3 squared, okay, multiplied by the quantity negative 9 plus x dx over ei. Okay, from 3 to 9. And we have what? Okay, kuha tayo ng calculator. We have positive 1,944 over ei. So, lagyan natin yan dito. Yan. Then, after which, sum up natin and we have positive 5,670 over ei. Okay? So, for the numerical value ng slope, so what is this? For theta b, what is this? Okay, kunin na lang natin yung magnitude, no? 918 over ei. But what is ei? Okay, yung e kanina ay I think 70, no? Okay. Try natin sa baba. 70. Okay. Gagawin natin tong kilonewton per square meter. Okay. So that is what? 70 times 10 raised to 6 kilonewton per square meter. Take note, 70 gigapascal is 70 times 10 raised to 9 newton square meter per square meter. So, ginawa natin kilonewton, nawalan tayo ng 1,000. So, raised to 6 na lang. And then, yung moment of inertia ay 500 times 10 raised to 6 millimeters to the 4th power. Okay. So, para maging consistent tayo sa units, okay, multiply natin to ng, okay, there are 1,000 millimeters in 1 meter. Okay, dahil naka-raise to sa 4, raise to 4 din natin to. Okay, kasi kailangan kilonewton square meter to. Dahil yung unit na ginamit natin sa force ay kilonewtons, sa distances naman ay meter. Alright, so cancel yung kilonewtons, cancel yung mm raised to 4, may m raised to 4 dito, meter yon. Meter raised to 4 divided by meter square. So magka-cancel nga siya rito. Okay, so get the numerical value. Ang unit nito ay radians. So kuha lang tayo ng calculator, and this is equal to 0.0262 radians, or equal to 1.5 degrees kapag multiply mo ng 180 over pi. Okay, in the same manner, ganun din yung gagawin natin sa deflection. Okay, ang mangyayari nga lang, magkakaroon ng unit na meter. So kung gusto mo ng millimeters na sagot, just multiply it by 1,000. Okay, same manner lang yung gagawin natin, and that is equal to, okay, 164.57 millimeters. Alright, so ito po yung ating deflection doon sa point B. So we have our second example to be next. For our second example, determine the midspan deflection of the beam shown. Use virtual work method. Okay, so we have a 200 kN load here and 100 kN load here. Ito yung gitna na midspan. So by statics, kunin natin yung reaction. 200 times 15 over 20 plus 100 times 5 over 20. That is equal to 175 kilonewtons. Okay, so 200 plus 100, 300 minus 175. This is 125 kilonewtons. Right? So kung mapapansin natin, meron tayong tatlong segments actually. Okay, we have segment AB, BC, and CD. But since we are concerned dun sa midspan deflection, kailangan 4 na segment yung gagamitin natin. Kasi mamaya, pagdating sa virtual system, maglalagay tayo ng unit load 1 dito sa midspan. That's why mahahati tayo sa 4. Okay? So, we have 4 cutting planes here. Kung mapapansin ninyo, yung dito sa part na to, ginawa kong origin naman yung point D for convenience. Okay? So, kahit saan naman actually pwede kang mag-originate. Okay? Ginawa lang natin siya for convenience. So, on your own, you can try to set the origin doon sa point A pa rin. Walang problema. Alright. So, what is the moment equation here? By the way, this is 175. This is 125. Lagay lang natin dito. 175. 175. 125. 125. Alright. So, we have what? M minus 175 times X equal to 0. So, simply, M is equal to what? 175 times X. Okay, for segment BM naman. Okay, so we have what? M minus 175X plus, okay, 200 times the quantity X minus 5. Kasi 5 meters to eh. Okay, ito no. So, X minus 5 equal to 0. So, rearranging, M is equal to what? 175X minus 200 times the quantity X minus 5. Okay? For segment MC, at ayan na, sinet natin na origin sa point D. So, nandito galing yung X natin. Okay? Convention, ganito yung positive moment. So, we have what? M minus 125X plus 100 times the quantity x minus 5. Okay, ito yan na. 5 meters din kasi ito. X minus 5 equal to 0. So, rearranging again. M is equal to what? 125x minus 100 times the quantity x minus 5. And last but not the least, ito naman, medyo basic na yan. M minus 125x equal to 0. So, M is equal to what? 125x. So, pakitandaan po yung apat na moment equation na yan. Mamaya ilalagay natin yan dun sa table na ginawa natin. So, dun tayo sa virtual system. So, this is what I am talking about, no? Naglagay tayo ng 1 unit load dun sa midspan. Kaya nahati tayo sa apat na segment. AB, BM, MC, and CD. Okay, just like what we did dun sa real system, kung saan ka nag-originate, dun din dapat manggagaling yung origin mo dun sa virtual system. So, these are all X's, no? Ito naman. Okay, yung member, yung segment AB tsaka BM, sa A tayo. Yung member or segment MC tsaka CD, doon naman tayo sa point T. Alright, so since nasa gitna naman to, ang reaction dito, obvious naman, tigkalahati. Okay, 0.5, 0.5, 0.5, and then 0.5. So, we're going to use small m para rin sa moment sa virtual system. So, we have what? M minus 0.5x equal to 0, or small m naman equal to 0.5x. Parehas lang din dito. Shortcut natin. M equals 0.5x. Paano naman dito? Uy, parehas lang din. Gets pa, guys? Okay. Then, syempre dito rin. M is equal to 0.5x. Nagkataon lang po yan, guys, na pare-parehas. Okay, that is just for convenience. So, lahat ng to ilalagay natin dun sa table. So, we have 4 segments here. AB, BM, MC, and CD. So, dito, mag-originate tayo sa A. So, as with this, A din tayo rito, no? Ito naman, parehas sa point D. Okay. So, mahalaga dito, guys, yung limits. Okay, kung nag-originate ka sa point A, ano yung magiging limits for AB? So, that is from 0 to 5. Okay? So, sa BM naman, ano yung magiging limits natin? Okay? Yung B ay 5 units from point A. At yung M ay 10 meters from point A. Maliwanag ko ba yan? Okay. So, for MC, okay, take note, nag-originate tayo sa point T. Okay. So, yung point M ay gaano kalayo sa point D? 10 meters yon. Yung C naman, 5 meters from point D. So, this is from 5 to 10. Okay. And then, for CD, it is obvious that it is from 0 to 5 meters. Okay. So, yung segment AB tsaka CD, 1 yung moment of inertia. So, I. Ito naman sa dalawang to, BM tsaka MC, 2I. Okay? So, dito naman tayo sa column na to. Ilagay natin yung mga nakuha natin na moment equation dun sa apat na segments. At ito po yung mga yon. And for this column, kung natandaan ninyo, lahat to 0.5x. Okay? So, ibigay ko na lang example tong dalawang to, no? So, for this one, for segment AB, paano naman natin solve to? So, this is what? Integral of 175x times 0.5x dx over EI from 0 to 5. And how much is this? So, we have, okay, this is 21875 over 6 EI. So, ilalagay natin yan dito. Okay, what's next? How about this one? So, this is integral of the quantity 175 minus 200 times the quantity x minus 5 times 0.5x over E times 2i. Okay, take note, 2i ito, no? Dx from 5 to 10. And this is equal to what? Okay? Rather, 175x pala to. Okay, so, compute natin. Okay, 90,625 over 12 EI. Okay, ilagay po natin yan dito. Positive 90,625 over 12 EI. Then, this 2, pwede namang input sa calculator. You can check it. Ilalagay ko na lang siya rito. These are as follows. Alright. So, after which, katulad ng ginawa natin, get the sum of these 4 values and we arrive to a positive 20,312.5 over EI. Okay? So, to get the numerical value, okay, ano nga ulit yung ating modulus of elasticity? Okay, yung E natin, remember, 250 gigapascal. So, 250 times 10 raised to 6 kilonewton per square meter. And then, yung moment of inertia natin ay 600 times 10 raised to 6 millimeters to the 4th power. Okay, katulad ng ginawa natin kanina, in 1,000 millimeters, 1 meter yon, raised to 4 to, no? So, we have what? To 10 raised to 12 to, no? Then, magiging 10 raised to negative 6. Okay, so this is 600 times 10 raised to negative 6 meters to the 4th power. Okay, so lagyan natin dito. Deflection at midspan M is equal to what? 20,312.5 is kilonewton meter cube. I remember yung mga unit na ginamit natin. Okay, kilonewton meter, kilonewton meter, kilonewton meter, meter, then meter, kilonewton meter cube. Okay, lagay natin na. Nasaan na yan? Ito. 250 times 10 raised to 6 kilonewton per square meter times what? 600 times 10 raised to negative 6 meters to the 4th power. Okay, cancel yung kilonewtons. Okay, meter raised to 4 divided by meter square, that is meter square. Meter cube divided by meter square, may matitirang meter. Okay, and ayun, no, cancel din yung 10 raised to 6. Okay, so kuha tayo ng calculator, i-add po ito. So this is 0.135467 meter. Okay, so times lang natin ng 1,000, so dito ko na ilalagay. This is what? 135.4167 millimeters. So, lagay ko positive, no? Ibig sabihin yan, ang significance ng positive sign ay in the sense siya nung direction ng 1 unit load na nilagay natin kanina dun sa midspan na pababa. Ibig sabihin, pababa din yung deflection dun sa midspan. At ang magnitude ay 135.4167 millimeters. So, I hope you get a lot of techniques in this video. So, stay tuned for other uploads. And God bless to all of you.